this video, we're going to learn how to use the fluorescence spectrophotometer, specifically the Turner Model 450 fluorometer, by analyzing a solution of fluorescein of unknown concentration using 3 other solutions of standard concentration. We begin by turning the power switch on. It's on the back panel, and allow for a 15-minute warm-up. Once the 15 minutes are done, this needs to be open, and we'll select and put in the appropriate filters in the sample compartment. The NB filter, in this lab we're using the NB 490, that'll go in the left compartment, just like that. And in the SC filter, for this lab we're using the SC 515 filter, that'll go in the compartment closest to you. If the lab needs an aperture slide, that'll just go right in front of either filter, but for this lab we won't need it. So, next thing we use is the cuvette with the blank solution. In this lab we're just using water, and we're sliding that right into the cuvette holder, and we'll shut it. And then we go down to these knobs. We set the span all the way clockwise until it reads 000, and then we go back just a little bit until you see numbers. And then we adjust the zero accordingly to make it zero out, just like that. And then we remove this. We remove the blank cuvette, and we take another cuvette and we'll fill it with the standard solution of highest concentration. In this lab, that's flask 4 with concentration 490 milligrams per liter. We use a glass pipette to transfer the solution, just like that. And we slide it back in here, close it, and if we need to, we'll adjust the gain to make it display, but in this case it's currently displaying. The span knob till it reads the appropriate concentration, and that is the concentration of the standard solution that we just put in. In this case it was 490. So and there we have it. Next, we remove this, and we can pipette this solution back into the flask. And then we take the standard solution of the next highest concentration. In this case, it's flask 2. We just take a little bit of it, put it in there, just to wash it out with the new concentration. And then we go over to the hazardous waste. We pour it in. And then we fill it up with the same solution. Once it's full, that should be full enough, we slide it back in, and we get a reading. And this is our fluorescence reading, or rather relative fluorescence reading. So we write that down, and then we repeat with the last standard solution. And so we pipette this back into flask 2. And then our last standard solution is in flask 1. It is 110 micrograms per liter, or milligrams per liter. We just add a little bit to it just to wash it out. Dump it into the hazardous waste. And we fill it up. Back in there, and then we write this number down, and again it's the relative fluorescence reading or fluorescence intensity. Once it stabilizes, we write it down and we take it back out, pipette it back into flask 1. And then we do the same thing, but with our unknown solution, and that's in flask 3. Pipe that a little bit in, rinse that into the hazardous waste. Fill it up. And we put it in and get our relative fluorescence intensity reading. And then we just put it back in. And use DI water to rinse the cuvette into the hazardous waste. Alright, and then you use the readings and concentrations from all 3 of the standard solutions and make a calibration curve using Excel. It should look something like this. You have the flask 4, flask 2, and flask 1, which are the 3 flasks with the standard solutions. You have the concentration here, the fluorescence reading here, and then those 3 points, you have the calibration curve, and you'll use the equation from the calibration curve and the fluorescence reading of flask 3, which is the unknown, to solve for the concentration